Okay, now we're evaluating definite integrals. And what that means is if we want you to find the area under the curve, and let's call this -3, this +1, we have defined the bounds. This is the lower bound. This is the upper bound. Because we've defined it, we can actually do the math and evaluate. That's what makes it a definite integral. But you use the antiderivative process. So that's what we did here. We took this integral so that the x value, that's x to the first, we added 1. 1 plus 1 is 2. So we divided 2. So that became x squared divided 2. And then the 2 by itself, remember that 2 by itself is x to the 0. So we added 1, then divide 1. That just makes it 2x. And now we can, and we put the bounds from 3 to 5. 5 is the upper, 3 is the lower. This is what we mean. This is upper. This is lower. So this graph is doing something like this. So it's saying, what is the area underneath that right there? All right. So the part that we haven't talked about before, once you have the integral, you take f. So once you have the integral, you take the area from f of the upper and you subtract f of the lower bound. So that's what we're doing right here. I plug 5 into the integral, and then we're going to subtract f of 3. And with your calculator or just by hand, simplify all of that. So this thing right here, so 45 halves subtract 21 halves is 24 halves, which is 12. So f of x, or another way that some professors are going to want to see it, is to put that original integral and then put an equal sign. And they may or may not want unit squared. This happens to be an area one, but not all professors will require that. Okay, so here's the original function. So we're going to, when we remove that stuff, we're going to add 1, divide by 4. So that will be x to the 4th over 4. And then this was x squared. We're going to add 1, divide by 3. But then this subtract 3, it's now being divided by 3. So that cancels. So that just leaves negative x cubed. And this 1 by itself is x to the 0. So add 1, divide 1. Well, that's just going to be x. We don't have to put 1 divide 1 because those things can be invisible. So now this is the function. Whoops, yikes. I needed a smaller eraser. This is the function that we are evaluating. Let me erase these arrows right there. So we're going to do f of 3 subtract f of -1, which is what I've done right there. So 3 in parentheses to the 4th, divide 4, subtract 3 cubed, plus 1. And then we're going to figure out that whole thing, which is what I've done here, each of those parts. And then we're subtracting, we're putting a -1 where all the x's are. And then just use your calculator or by hand do that. And there's 2 different ways to write it. I'm going to want to see it that way. But there might be some professors that allow that. Okay, for number 18, when there is anything x squared or above, if it's 2 over x, the integral of that will be an ln, and we'll do that in a little bit. So anything that's x squared or above, you're going to rewrite it. So we wrote it x to the -3. So when you go ahead and take the integral, notice this is what we're doing right here. We add the 1, that's -2. We divide by -2, and then notice those cancel, and that leaves -1. In fact, we could even do that if you want, just to emphasize that. In fact, I'm going to do that. So then when we do f of -1, subtract, because remember, this is the upper, this is the lower, and it's always upper, subtract lower. There's a negative on the outside. So that's what we've done right here. And you plug that into your calculator, and you end up with -1 plus 1/16, which is -5/16. So other way to write that is f of x over x cubed dx is -15/16. Sorry, the phone rang. All right, so -15/16. And the area is not really a negative area. What that means is the graph, the curve, falls somewhere below the x-axis. So a negative amount on an integral just means that that graph, and if you look at the original, if you were to type it in, part of that graph is going to fall below the x-axis. And so we go ahead and write it like that. And then when we do the approximation, go out at least 4 decimal points. Okay, we're jumping down to number 22, and it's going to be one of these interesting ones where it's the integral ends up the ln, whoops, and then the absolute value of the argument. So this right here essentially says -2 over something, right, to the first power, which is why we're not going to write it as this. And so whenever you have a function that looks like that, the integral is going to have an ln as part of it. Okay, so we're going to use the u substitution. So this part right here is the u. And so the du is just 1 dx, because the integral of x is 1. But we need it to say -2. So we're going to multiply both sides by -2. We're going to pull that out like that. And now we're just integrating 1 over u. Well, the function whose derivative is 1 over u would be the ln of u. So if this is the function, the derivative would be 1 over u times the ln of e, which would cancel. Oh no, this is not good. I'm having some technical. So the ln of e, but the ln of e is one that cancels, and the derivative of u is 1, so 1 times 1 doesn't change anything. So when you integrate this with the -2 out front, that -2 will stay out front of the integral of 1 over u, which is ln, the absolute value of u, but then u is substituted with the x plus 1. And then we're going from upper, lower bounds. So when you plug that into here, so there's 2 ways to do it. We could remove the outer brackets And we could put -2 here, subtract -2 here, so that would be adding a positive. Or what I recommend is putting that whole thing in brackets and leaving the -2 on the outside. So simplify all of that, bring that down here, simplify this, and then just do the distributive. Negative times negative becomes a positive. So there you have your answer. Okay, what I'm going to do for the rest of this video, I'm just going to go ahead, and this is, Gigi, this is for anybody else. I'm just going to leave these steps up here. Hopefully these are upper and lower bounds. To see the process, you can freeze the screen when you feel like it. Now this one says, but do not evaluate. So I went ahead and put it in U notation. They just want you to set up what the integral would look like, but then don't evaluate. So I'm just going to leave that up on the screen. So this thing right here is the U. Okay, this is going to be a different video, so I'll go ahead and pause now or stop this video now.